class. I did evening class, and I did food and nutrition.
Hold on, pause. You had math today?
Repeat, sir?
You had math today?
Yes.
We did math class.
No, I did not do any math class.
You didn't do any math?
No, not today.
Oh.
Only did math 2 times a week.
When? Tuesday, Thursday?
Yes. No, Thursday, Friday.
Thursday, Friday.
Yes.
What you started last week? Last week Thursday, what did you do?
Well, we didn't start anything, but we were doing matrices. We're now at the inverse of a matrix.
You're now at the inverse of a matrix.
Yeah.
Oh, so you're flipping a matrix.
Yeah.
Okay. So you understand what you're doing in inverse of a matrix?
Yeah, I understand it, but I need more practice.
What is the inverse of a matrix? What does it mean?
Basically, I can't really explain it, but I know how to do it. So, like, you would be, when you're finding the inverse of a matrix, you would first put 1 over the determinant of that matrix. Then you multiply it by the adjoint of the matrix.
You multiply it by the adjoint
of the matrix.
Okay, so matrix A is 2, 3, 4, -5. Matrix B is, give me some numbers.
4, 5.
Last number.
6.
Did you multiply matrix already?
Yes.
Okay. All right. So A times B A times B would be equal to what?
Okay. Give me a minute.
Give you a minute?
Yes.
Takes you that long to work it?
Okay, roll back. So first you would have 2 times 1.
Yes.
Plus 3 times 4.
So that is 2 plus 7. What is 2 plus 7?
2 plus, 2 plus 7 is 9.
Is?
9.
9.
Wait, 7, sir? 7? It's 3 times 4. It's 12.
Oh, 12. So what is 12 plus 2?
12 plus 2 is 14.
14. Okay. What next?
By the other side, it would be 2 times 0 plus 3 times 6. Which would
so that is 0 plus 18?
Yeah. For the bottom one, for the first one, it's 4 times 1 plus -5 times 4.
Okay, so that is 4 minus 20?
Yes.
What would that give you?
-5 negative 16.
Okay.
Then 4 times 0 plus negative 5 times 6.
That's 4 times 0, 0, negative 5 times 6, negative 30. Right?
Yes, that's the answer.
Now say you find A times B.
Yes,
How do you divide a matrix? Can you divide, you know division in matrices?
no, you don't reach there yet. But
Don't reach here.
I think maybe I can do it. Maybe, but I didn't do that as yet.
Yeah, but you're going to ask a teacher about it. Could
Well,
ask your teacher and hear what he or she says. Not sure.
yes, I will.
Uh, what is 1 times A? What would that be equal to?
1 times 8.
Yeah, one group of A is what?
You mean as in like in terms of
Okay, when you multiply 1 by A, what would you get?
A?
A. Okay. That's one group of A, not true?
Yes.
All right. I'm going to ask you what this means, but I don't want you to answer it yet. What is 1 divided by A? I'm going to ask you what that means, but I don't want you to answer it yet. So we were doing indices, right?
Yes.
And if I had B to the third power, hello, Tissan.
Hello.
How are you doing?
Hi.
Minus B to the fourth power. What would that be? Divided by, sorry. I'm thinking about minus in my head. If you have B to the third power divided by B to the fourth power, what would that be?
B
Mm-hmm.
to the negative 1.
Oh, you get, tell me how you get negative 1. I can't understand my negative 1.
Oh,
3 minus 4.
I don't know actually.
3 minus
4.
4.
3 minus 4, the same thing as what? B raised to the power of what?
Negative 1.
Negative 1. I want to represent this another way. Stalin. I want to say, I want to use the vinculum. So B to the third power, what does it mean?
B times B.
Can you tell me 1 times what?
B times B. Times B.
That's what it means, right?
Yes.
Yeah.
Okay, what about B to the fourth power? What does it mean?
1 times B. Times B.
B.
Times B.
B.
Times B.
C.
Right? Now, what do we do here when division says division is repeated what? Hmm?
Well, first and foremost, I would cancel the B. The things that are in common. It are the B.
Yeah.
So B would cancel. So there are 3 B's at the top and 4 B's at the bottom. So it would eventually leave me with 1 over B.
All right, let us see what happens. So you say you would take 1 from the bottom, take 1 from the top at the same time, right?
Yeah.
Yeah.
Okay, cool. One from down here. One from down there. Cool?
Yeah.
Yes.
One from here. One from here.
Yes.
We good?
Yes, that's exactly
So what are we left with? What's at the top? I'm going to write, yeah, I want to write this as fractions. What's at the top?
1.
1 over b to the negative negative 1.
One group of b, which is the same thing as 1 over b, not true?
Yes.
Yeah.
All right. Is this the same as this?
Yeah.
Yes.
Yep.
What did I do here? What action did I perform?
You basically found
You subtract.
the inverse of B.
Well, no, what action did I perform?
Division.
Division. You see that?
I get what you're doing.
So 1 over a is the same as a to the what?
A to the negative 1 power.
When you do the inverse for a matrix, how they tell you to write it?
A to the negative 1, I always forget what it is.
So if they ask to find the inverse of a, they will tell you to find a raised to the what?
Negative 1.
That's the inverse of a matrix, you know.
I realized, sir, so they're telling me that when they tell you to find the inverse of a matrix.
You're doing division.
Yes.
Yep.
I didn't realize. I didn't realize that.
Because there is something you're going to figure out when you start matrices or when you go deeper into matrices. I'm not sure your teacher will point it out to you, but I always point it out to my students. You know the identity matrix?
Yes.
What happens? I'm going to work out a little bit down here. Alright, so the identity matrix is what?
1. Oh, I equals.
Yeah.
1, 0.
1, 0,
0.
0. What happens if I multiply A by the identity matrix?
If you multiply?
If I take A and I multiply it by I, what will happen?
You will get back A.
You get back A?
Yeah.
Really? Let us see. 2, 3, 4, negative 5. Right. Times I. 1, 0. So ask you what you do today, Tucson. You did math today, Tucson?
Yeah.
Yeah? Alright. You need to get your math book. Because this evening's class is a little bit unorthodox. It will end earlier because I was actually waiting until 6:30 before I left. But Sawin came and I heard a preacher say something one time. He was making an analogy with a farmer. He said a farmer went out to feed his chickens. So when the farmer went out to feed his chickens, normally the chickens know what time the feeding is going to be done. And everybody would come to get the feeding. And he would feed them. But one day, only one chicken came. And the question was asked, what do you think the farmer should do? Because the one chicken come, don't feed him. What would you do, Staway?
Feed him.
What would you do, Tisan?
Feed the one chicken.
Okay. So in that sense, I indeed made an effort. I was going to make an effort to feed the one chicken. I wouldn't give the one chicken the whole feeding though, so I wouldn't spend the whole the whole time, but I would still feed the 1. Alright, so I would give the 1 enough for the 1 to walk out satisfied. So Stawin is actually looking at matrices, and she is doing the inverse of a matrix. So I just showed her where the idea of inverse came from. She said she do multiplication. I asked her if maybe if they're going to the division, or she should ask her teacher if they're going to the division. She said she don't know, or she's not sure yet, but they don't actually call it division. They look at it like this from a matrix perspective. See that? Yeah, so we were looking at A times I. What will happen? So let us run through the multiplication again. Stawin. What's my first entry?
Okay, the first thing is 2 times 1 plus 3 times 0, which would be 2.
2. Okay. Second entry.
Going down, up, across. 2 times 0 plus 3 times 1, which would be 3.
Go again. So it's row 1 times column 1, and then you have row 1 times column 2.
Repeat that, sir?
No, you just did row 1 times column 1, so now you're doing row 1 times column 2.
Yes.
So what will happen? So it's 2 times 0 plus, so that is 0 plus 3, right?
Yes, it is 3.
Okay, so that's just 3. What happens down here?
4 times 1 plus negative 5 times 0.
And your result is?
4.
4. Do it in your head, Stawin. Try to do it in your head. Because remember, you're adding 0 to a number. So capture it in your mind. So row 2 times column 2, you're capturing it in your mind now. So it is 4 times 0, 0. So you put that somewhere in your mind. Plus negative 5 times 1, negative 5. So now you have 0 and negative 5. What's your result?
Negative 5.
Negative 5, yes. Capture it in your mind. So what you see happening when you say A times I? What's the result?
You get back the same as the same set of numbers you got.
You get back A.
Yeah, you get back.
What's the identity of multiplication? We spoke about it. A number that if I multiply it by 3, I will get back 3. Or if I do that number, if I do it the other way around, I will get back 3. What's that magic number?
1.
1. That's why they call it the identity
Only
of
1.
multiplication. So in the matrix, what they call this kind of matrix? What they call the matrix? This. What the I stand for? Comes to in.
Identity.
It's identity, and this is why it is the identity matrix. See that?
Yes.
Question: if I did I times A, will I get back the same thing?
I times A. I think so,
Yeah.
sir, because it doesn't really matter where you're multiplying.
Yeah.
You think so? Test it
No, I
now.
think I will get the same thing.
Focus on this I and look, and we'll use this A. Alright? So we're just going to use this for convention purposes because one is before the other, like one is before the other here. So we're going this way. So it is row 1 times column 1, right? So 1 times 2 plus.
2 plus 0 is 2.
So it's 1 times 2 plus 0 times 4, which is what? 2. So now row 1 times column 2. So 1 times 3 plus 0 times
negative 5.
Which is 3 plus negative 5. 3 plus 0, which is what?
3 plus 0 is equal to 3.
Is equal to what? I'm not going to write anything until you tell me. 3.
3.
All right. Row 2, column 1, 0 times 2.
So 0 times 4.
Come on, you should be telling me, you should be writing down anything. 0 multiplied by 2.
Yes.
That's what?
Oh, that's 4.
0 multiplied by 2.
Oh, it's 0, 0.
0 plus 1 times 4.
4. So it's 4 plus 0, which is 4.
The last one now, 0 multiplied by 3.
0.
1 times negative
1
5.
times negative 5, which is negative 5.
Negative 5. So you see that?
Yes.
You still get back what?
The 8. Still get
Still
back
get.
the
So yes, you are correct. That's the identity of multiplication, of matrix multiplication. That's why it's called the identity matrix. So just like how you have 1 times 3 or 3 times 1 giving you 3, the identity of multiplication, so too is that the identity of matrix multiplication. All right. I'm going to show you where this comes now. When you're about to finish doing matrices, you see, you're going to learn how to use a matrix to solve a simultaneous equation.
Oh, I'm doing that too.
Now, when you set up the simultaneous equation, you're supposed to get AX
Equal to
equal what?
B.
B, where that X is a capital X, which is the variables, the X and Y variables, not true?
Yes.
Hmm?
Yes, sir.
Now, look at this equation right here, the simple equation. How would you solve this equation for X? What would you do to make X the subject of the formula?
B.
I'm just writing back the equation, I'm not doing it. What would you do to make X the subject of the formula?
So since you divide A by both sides, it should give you B.
You divide A by both sides. Say that the other way around.
A inverse, you multiply it by both sides.
You multiply A inverse by both sides. Where does the A inverse come from?
You're dividing.
You're dividing what by what?
You're dividing both sides by A.
Both sides by A. Yes, this is how you do transposition. If you want to make A the subject of the formula, you must divide both sides by A. So what happens there? It goes away. Anything you do on one side, you have to do it on the other side. Not true?
Yes. So it would be the denominator.
So now you have X is equal to who? B over A, not true?
Yes.
Question, if something is sitting on top of A, is there another way to write that A?
Yes.
Huh?
A denominator, it would be B times A inverse.
It would be B times A inverse, yes. But you're going to find out something whenever you're multiplying two things in, you're going to find out something when you're multiplying two things with matrices, especially with A and B. You would say it's B times A inverse, but it's also the same thing as me saying A inverse times B. And the convention here is very important because if you multiply A, B times A inverse, you'll get a totally different answer. All right?
Oh, yes.
It's very important that you call it A inverse groups of B because you want to find out the, yeah, it's just as how 3 groups of 2 and 2 groups of 3 are different. Just like how those are different, it means something different. I'm not talking about the number, but it means something different. The meaning here is what comes into play. The meaning here is what gives you the solution for X. Right?
Yes.
It's A inverse groups of B. Because remember, the meaning here, 3 groups of 2, means that you have 1 group of 2, 1 group of 2. Means that you have how many groups of 2?
3.
3. So the 3 here is like the boss, because you tell us you have 3 we want. And then the second number just tell you how much not the 3. As opposed to this, 2 groups of 3, as opposed to this.
Yes. 2, 3.
See that?
Yes, sir.
That is why when we teach you multiplication conceptually and addition conceptually, we try to go, or we make it our best effort to show you what the meaning is, and this is how you apply the meaning at a higher level. Because if you do B times A inverse, it will give you a different answer than A inverse times B. And you can test it and you'll see.
Okay. So you would
Want us to test it?
that B times A inverse would be different from A inverse times B.
We're going to test it. Because I don't want I want you to be fully converted when you leave this sermon. I don't want any doubt in your mind. Fully converted. So when you finish your sermon out right now, you're supposed to kind of just baptize inside. Right? Fully converted when I finish the sermon. So let us see what it says. We're going to first do B times A inverse. And we already have B and A inverse in front of us, so there's no need to. Did we find A inverse?
No, we didn't.
So we need to find A inverse. Alright. We have A times B. We don't need this. We established this already. I hope you took some notes.
Yes, I did.
Alright, good. We need B, so we're going to keep B. Alright, so B times A inverse. A inverse is 1 over what we call the determinant of B.
Yeah.
And there's another way to write determinant of B. That looks familiar?
Oh, I didn't learn that one. I think that
You learned that one?
By the way, sir, it's not the inverse of B, it's the inverse of A.
Inverse of A. Thank you so very much. I am so focused on B. So it's 1 over the determinant of A times its diagonal. Or sometimes they'll say the adjoint. Right? A, D, J. So what is this?
So the determinant would be A, B minus B, C.
Tell me in terms of numbers.
Okay, it would be B, sorry, not B, 2 times negative 5,
Which gives you what?
negative 10,
Minus who?
minus 3 times 4, which is 12,
What do you get at the end of the day?
negative 2.
Negative?
2. 20. Oh,
Careful. Careful.
negative 22.
Negative 22. What about the adjoint of A?
The adjoint of A would be, you would switch the A and the B values and you would change the sign of the B and C values.
So switch A and D. So
Yes.
put 5 where 2 is and 2 where 5 is.
Yes.
And change the sign of 3 and 4, turning them into -3 and
Negative.
-4. And this is just a method to the madness. Right? That's what we call it. Method to the madness. So inverse is therefore inverse is therefore 1 sitting on top of -22. And we're going to multiply it by what? -5, -3, -4,
4 and 2.
2.
Okay.
What happens now?
I would say negative. No, not negative. It is 5. Would it be 5 over 22?
5 over 22, yes, because negative
And
divided by negative,
it's a positive.
yes. Right, I'll soon derive that. I'll soon show you how that come about. What of the second entry?
It would be 3 over 22.
Same story, yes. This entry down here,
4 over 22.
4 over
22.
or 4/22 as a fraction. And the last one is what?
Negative 2 over 22.
-2 over 22. Knowing that the negative sign can go anywhere, either at the top or at the bottom. It's still in the fraction. So it doesn't matter.
So that's the inverse of
Some
3.
students don't see that so easily. Yes, this is the inverse. So now, knowing that this is the inverse, we're going to do b times the inverse of a. B was 1, 0.
Okay.
Hold on, plugging in this laptop before it dies. How do I go forward? Control C, Control go forward. All right. No, I don't know. Control V. I have to rewrite all of that. Something. Stop it foolishness. All right, so stretch this bracket. Stretch bracket. B times A inverse. Let's just take the numbers. Stretching your mind out the way in. So row 1 times column 1. Is there a 0 in the first row in B?
Yes.
So what number only comes back then?
0. If it's multiplied by 0, it would be 0.
So the second number in the first row of B is a 0. Therefore, the only thing that will come back is the number that 1 multiplies, which would be what?
5 over 22.
5 over 22. Beautiful. So now, now we have row 1. We did row 1 times column 1. So now we're doing row 1 times column 2. I think I need to erase this. Now, whenever you're doing matrices, leave everything like it is right here. Even though you can reduce in this case, right here and right here, do not reduce them, all right?
Okay.
Do not reduce until you're at your final answer.
Right.
So now we're at row 1 here, multiplying column 2 down there. So 1 times 3 over 22. What will that be?
3 over 20.
3 over
22.
22. Plus who?
So it would be plus 0 because when you
Will be,
multiply,
yeah, because remember now, I wanted to see if you're going to say it. Remember now, because 0 is the second entry in the first row of B. Then the only thing we need to look on is the one that 1 is multiplying. So it will just be 5 22 and 3 over 22 for the first row. Coming down now, row 2. What is 4 times 4 over 22?
uh, 4 times 4 over 20. Give me a minute.
Or what should you do first? Is row 2 times column 1. So it's 4 times 5 over 22. So
Oh,
it's
yes. 4 times 5 over 20.
row 2, column 1. So 4 times 5 over 22. What is that?
I got 10 over 11.
What is 4 times 5?
20 over 20. Oh,
22. Leave
20
it. Do
over
not reduce. Yes, do not reduce. 20 over 22. Plus who?
plus 4. Alright. 6 times 4, which would be 24 over 20.
24 over
22.
22. All right. Coming over now. So this is under this. This is one thing. We're gonna have. We still have one more thing. Oh, don't need that yet.
For the second column.
For the last entry, second row, second column.
It would be 4. 16 over 22 plus.
So it's row 2 times column 2.
Oh, sorry, that
4
was
times 3.
12 over
4,
22.
12 over
Negative
20.
12 over 22. Plus
And that is 6 times negative 2, negative 12. Plus 2 6 is 12, negative 12 over 22. Okay, so now this is B times A inverse. What will that give you? That will give you 5 over 22.
5 over 22.
And then what?
3 over 22.
What is 20 plus 24?
44.
44 divided by 22.
44 divided by 22. 2.
2. 12 minus 12.
0.
0. So that is your answer if you say B times A inverse.
Yes.
What would happen if you say A inverse times B? What would happen if you said A inverse times B? Come on, eraser.
Okay, so we already know the inverse of, which is 5 over 22, 3 over 22, 4 over 22, negative 2 over 22.
Making space to find out what will happen. Something beautiful will happen.
Repeat that.
I say making space to find out what will happen. Something beautiful will happen. Bam. Now we're doing A inverse times inverse times. And And there is something profound to that will always tell you to put A inverse first. But we look at it after you're finished working on it. They say A inverse is this, right?
Yes.
Okay, so we can just multiply it by B. You good like that?
Yeah.
All right, let us go.
It would be
Row times column, so it's first row times first column.
okay.
The first entry will be what? You're multiplying a 5 over 22 by 1.
Yeah, so it was 22 that times
5,
1.
and then
322 times 4.
yes, so 3 times 4,
Yeah, which is 12 over 22.
12 over 22. Do-do-do-do-do. That's the
Then
first entry, row 1 times column 1 coming over. Second
yeah,
entry, row 1 times column 2, that is row with 5 and 3, you're going to multiply it by 0 and 6. So the first thing you're going to get is a 0. Is it necessary? Do we need it?
no, because you're adding.
Yeah, so we can just focus on the what?
So we multiply 3 over 22 by 6, which would be equal to 18 over 22.
18 over 22. Yes. Coming down now, row 2 times column 1. What's that first entry going to be?
Okay. I got 4 over 20.
Yes.
4 over 22 plus
Plus
negative. Oh yes,
negative
plus
what?
negative 8 over 22.
Over 22. Yeah. And the last entry, row 2 times column 2. There's a big fat 0 there. So what happens?
0. It would be 0, so it would be
So the only thing we're going to use is the 2 times 6, which is?
which is 12, negative 12.
Oh, 9 look like a 72. Hold on. That's negative 12
Yeah, over 20.
over 3. Already your answers are different. Look at the last entry down here. Look at the last entry here. See that?
Ah, you make a note of
This,
am I right?
this, what will this give you? This will give you, this is coming from here. Be coming around the mountain when she comes. Boom. So that will give you 5 plus 12. 17 sitting on top of
18
22.
over 22. 18 over 22.
18
4
sitting on top of 22.
negative 4 over 22.
4 minus 8, that's negative 4 on top of 22.
Yeah.
And then down here we have negative 12 on top of 22. Are they the same?
No.
No. So it reinforces what I was saying before. Is it 3 groups of 12 and 4 groups of 3? 3 groups of 4 and 4 groups of 3 mean something different. And you see how different it is when you actually look at matrices.
Very different.
Yes, it's two quite different things. So that is totally different from that. Totally different. So next time around, if somebody asks if 3 times 4 and 4 times 3 is the same, or they mean the same thing,
No, they don't mean the same thing. They
they
might
mean
have the same value, but
they have the same arithmetic value, and it's only because they're single numbers.
yeah.
So they're commutative here. But when you touch matrices, it's not commutative. So if you have one matrix A times another matrix B, it does not communicate, or it is not the same as if you did turn them around, B times A. That not
Yes,
commutative. That's the beauty about matrices right here.
you
Won't
make,
work.
I'm
You
making a
should
note
make a
of
note of that. And if you look on your CXC question, sometimes they'll say, is A commutative with B? Or sometimes they'll ask you, what's the relationship between matrix AB and matrix BA? I've seen it on about 4 past papers already. One as recent as last year, or 2016.
what is the relationship between.
So AB and BA, when you talk about matrices, it's not commutative.
No, it's not.
Yes, they are not commutative. It's not like 3 times 4 and 4 times 3, where both of them are 12. In matrices, as you can see right here,
They are different.
everything about them is different. You not even find one similarity. Well, this is 5 over 22, this is 17/22, this is 3, this is 18, this is 2, this is 4, this is 0, this is, yeah,
Maybe it's
nothing different, nothing the same. Right?
understood. Made a note of it.
Yeah, yeah. Not commutative. This one,
Yes.
talk to me. What want to do today? You did math today?
Yes, I did math today.
What want to do in a math?
We did
Hmm?
standard form.
Standard form. Okay.
Yeah.
So Stawin, here's a little revision coming your way.
Yes, sir.
Standard form. What does standard form mean?
Yeah. Mm.
What is standard form, Tisan? What does it mean?
Like when you express numbers in
So if I have the number 36, so how do you express that in standard form?
if you have the number what?
It's right there. Check out my screen. 36. What's that in standard form?
$36.
Yep, 36.
You can times it by 10 to the first power.
10 times by 10 to the first power.
Yeah.
So I should do like this. That would give me something different, Tisan. That would give me 360. Not true.
Yeah.
It would change the meaning of the number. I don't want to change the meaning of the number. You're on the right track, but organize it in your mind first. Or maybe because of how it was introduced, you're not seeing the link.
So standard form is a way of writing down very large or very small numbers easily.
Yeah, it's a way of writing very large or very small numbers. But what's the rationale behind it? What is the rationale behind it?
What I mean?
Why does it make sense? Normally, when somebody asks the rationale behind something, they want to know why it makes sense. Tell me no, me wait for you. Now what you do?
So,
Can
the rules when you're writing down a number in standard form. First, you have to write down a number between 1 and 10. Alright?
that's right, a number between
1 and 10.
has to be a number between 1 and 10, alright. I'm missing all the eyes. Stop you, can you tell me? My gosh. No, it don't look like I want it to look like. It's your fault. It's your fault. It's her fault, not true, son. Yeah, man, you're quick for cast blame. You? I'm a good somebody. You're a good somebody, man.
So after you do that, you go,
So we don't just put DP.
Oh, man, I don't
you
want to
go
put DP because DP might mean display picture. Or don't press. That's a decimal. And the decimal is a point.
yes.
Alright, Sammy. This is standard form. Long ago, this is the Earth. This is the Earth. That's the Earth. Or maybe I should draw the Earth in blue. And this thing up here, what do you think this thing is?
So
Thing.
What is this thing up here?
What's that?
Talk to me now.
What is that?
What does it look like? If this is the Earth, what would this be?
The sun.
The sun. All right. So, mathematicians of past and physicists and astrologists, they did something, right? And it's still an estimate up until today. The estimated distance of the Earth to the sun. Now, when they estimated this distance, do you think it's the same distance from? You think it's the same distance from KFC to your house? Huh? Do you think the distance from the Earth to the sun, the distance from Westgate to Portobello?
No.
So the distance from the Earth to the sun, so the distance from Westgate to Portobello is 3 kilometers. Do you think the distance of the Earth to the sun is also 3 kilometers, or could it have been 3 kilometers? No, talk to me, no man. Don't make me feel like I talk to myself. I'm not mad on a Monday.
nope.
What you say? What you say to son?
Wait, I'm thinking about it. Go on to story.
You're thinking about it?
Yes.
Alright, question. You have a stove in your house, not true?
Yes.
Or your parents have a stove? You don't have it. Your parents have a stove. When the pot are cook, you see? And you stand up outside, can you feel the fire?
No.
When you feel the fire?
Near it when I go in the kitchen.
When you go in your kitchen, when you put your hand near the flame, feel hot or it feel cooler?
Hot.
Huh? When you're laughing after me?
Hot.
Hot or it feel cooler?
Yeah.
You feel hot, not true?
Yep.
Yeah.
When you go outside, the sun feel cool or the sun feel hot?
No, say hot.
Not you.
Yes.
Hot fire.
You know how far away from the sun we are?
Um, some millions of miles.
Yeah.
We are 149.6 million kilometers from the sun.
That's very far.
Let me put it in perspective for you. You see, I'm going to Google Maps it right now. I'm going to Google Maps distance. I'm going to use a distance that both of you know. And that is from, let me look for it, maps, MAPS. Where do you live, Christian? Tell me where you live again.
Cornell quartz.
Cornwall Courts. Where do you drive to go Cornwall Courts?
Where you drive?
Alright. Both of you know Westgate, right?
Yes.
Yeah.
Alright. Both of you know Iron Shore?
Yeah.
Alright. So we're going to use a point where you want to know.
Oh, so you can drive. Wait.
No, man. We're going to use a point where both want to know. Westgate.
Westgate Hills.
Westgate Shopping Center. And we are
It's too
going,
much.
yeah, man, the whole shopping center.
Um,
I'm going to give you the kilometers because my Google Maps have everything in kilometers. So I'm giving you so, Westgate Shopping Center. This thing type something about Carolina Avenue. This thing is even something about here. And because my location is somewhere in Ottawa. Ottawa is where? Canada? Canada? Westgate Shopping Center, Montego. And we're going, you say both of you know Iron Shore, right?
yes.
Iron Shore Shopping Center. All right, so from Westgate Shopping Center to Iron Shore Shopping Center, the distance is 8.9 kilometers. What did I say the distance was?
8.9.
8.9 kilometers. You didn't miss much, Stawin, just the distance from. So this is the distance from Westgate to Iron Shore. Question, would you want to walk from Westgate to Iron Shore?
No.
Hmm?
No.
Would you be willing to walk from Westgate to Iron Shore?
Nope.
All right. Now, if you can imagine that distance being so far, look at the distance from the Earth to the Sun. This is 8.9 kilometers now. You see how far this is? And the distance from the Earth to the Sun is 149.6 million kilometers. How many kilometers? How many times would you have to go back and forth Westgate and Iron Shore in order for you to travel the same distance as you would the Sun? Hmm? Take out the calculator, girls.
I
Have a
apologize for that, sir. My internet went a while ago.
Yeah, I saw that. Push. Take out my calculator. I want to do this. Do the math for me. Divide 149.6 million by 8.9.
Million?
You don't know how to, let me show you how it looks.
Million.
You want 149 million. And it's a 0.6 million, it's a 0.6 of a million is 600,000.
Okay. 49.
That is 100, that's what 149.6
1,
million looks like.
2, 3, 4, 5, 6.
Yeah man, use my comma them, so we put it.
Divided by, oh, see here, divided by
8.9.
1.68 times,
What the calculator say? 1.68 times
10 to the
10 to the
7th power,
7th power. What does that mean?
or 16808
1.68
08
0. What does this mean?
8
Hmm?
16808
08
988
988. So I'm using commas.
8.76.
Alright, we know one. Alright, 0.76. I think I want to go for this small point now. 0.76. Let us use our commas now. 3 digits, comma. 3 digits, comma. So, to go from, to equalize the distance from the Earth to the Sun, if we're going to use Westgate and Iron Shore, that means you'd have to go back and front from Westgate to Iron Shore. So you'd have to go Westgate one time when you come back to Iron Shore. Or when you go Iron Shore, you come back at Westgate. You go Westgate, that's a 1, come back at Iron Shore, that's a 2. You know how much time you'd have to travel that distance? You'd have to do it 16,808,988 times.
Oh boy. That's
If you did,
basically your whole life of traveling.
if you did this 1 times for the day, so go and do it once a day. Divide this by 365 for me. We want to see how much days you should have take. We want to put it in days. Divide by 365.
46,000.
Lord of mercy. 46.
6,000.
46,000.
46,052.
46,052.
Yeah.
So it would take you. So this is the amount of days that it would take. 46,000. You have some point?
Yes, 02401. That's it.
As a matter of fact, you know, when you divide by 365, you know, the 365, how many days make a year?
365.
365, so we actually divided by a year here. So this is the amount of years it would take. Who can live this long?
Years? You sure? Wait.
We divide it by 365, split up into days. Well, yeah, 46,052 days. So it's in days, sorry. I was thinking here a while ago. If we should divide this, even before we continue dividing or whatever, the point I'm making is this. You see this big number right here? Is there a simpler way to write it, this one?
Yes.
She gone?
Huh?
Is there a simpler way to write that big number?
Which number that?
The 149.6 million. See it up here. Is there a simpler way to write it? She gone. It's from 7:30. Jumping out. Well, it's 7:30. Is there a simpler way to write this number?
Oh, if you're asking if there's another way to write this number?
A simpler way, a shorter way.
Oh.
Because the standard form comes from, you had some huge numbers. People working with some huge numbers. But to express all of these big numbers, it took up too much space and too much time.
Yeah.
So they came up with a short way system to represent very large numbers. And that short system of representing very large numbers stems right from what we did last time. Right? It stems right from this. So you have the ones, you have the 10, then you have the 100. What you have after?
1,000.
1,000. Then what you have after?
10,000.
100,000.
Then you have 100,000. I'll just write 1,000.
1,000.
Yes, 1,000. After 100,000, I have what? If you have 1,000, you have 100,000. How much you have? You got $1 million, and we're talking about meal here, not money. They have $1 million. Now, what does this look like? In terms of 10, what does ones look like in terms of 10? Remember, one group of 10 is the same as 10 to the 1. Not true?
Yes, sir.
10 squared is the same thing as 100. Not true?
Yes, sir.
Yeah.
10 to the third power is the same thing as 1,000, right?
Yeah.
Yes, sir.
10 to the fourth power is what? 10,000.
Oh, 10,000.
10 to the fifth power is the same as what? 100,000. And 10 to the sixth power is the same thing as what?
1 million.
1 million. So what 10 to the what goes here?
0.
10 to the 0. Because that is what gives you 1. So now, the number 36, you see? If you should represent 36 in terms of its unit of third, what the face value, what's the face value of this right here? What's the face value of this?
Face value?
Face, as in my face.
Face value again.
When you look at it, what do you see? You see a what?
I see a 3 and a 6.
Yeah, 3. That's the face value. You see a 3.
A long time.
Second question, what is the place value?
3 tens. 6
3
1.
tens or 30. Yes. So the place on our chart would be here.
Yes.
30 and 6 because there is no point, so it doesn't go here. You see that? So the face value is a 3, but its place in our chart, in our decimal chart, or in our denary system chart, its place is under the tens. See that?
Yes, sir.
So standard form is really writing a number, firstly using its face value and its power of 10. its place in the chart. So 3.6 in standard form or in a form standard to our denary system is 3.6. And the idea of standard form is that you want only one number in front of the decimal place because you want the number to look as simple as possible. So it is 3.6 times 10. What is the place value of the highest number or the biggest place value? What is the place value?
1.
10 to the what? 10 to the 1. You see that, Tisson?
Yes.
So, what if I had this big number and I couldn't bother to write it? What if I had $41 million? What if I had 41 million? And on a check, I kind of run out of space and I'm running out of ink, but I still want to tell you that I'm writing you a check for $41 million. Can I put this in here?
Well, it wouldn't hold.
It wouldn't hold.
No.
All right, let me use a simpler number. 4.1 million dollars. Rubber, before I go to that big number. Bing, bang, bang. 4,100,000. What would I do with it? How would I put it in? What comes first? Let's just go from this side. Let's just put it in the ones. What's in the ones place?
0, 1.
0.
1, 0, 10.
0. 0.
1,000.
0.
0, 10,000.
Yes. 0.
100,000.
100,000. How many millions?
4 million.
4 million. What if I only want this number in terms of in standard form? I want it in simple terms. I don't want it in big terms. What's the first place value? 4.2.
1.
4.1. What is the value of the number, the highest place,
6.
in terms of its power of 10?
Some millions say would be 6 value. 6.
10 to the?
6.
Yes.
Sir, what I would normally use, at my level, it's not so simple. So what I would normally count is the amount of numbers behind the first digit.
So you would say 1, 2, 3, 4, 5, 6.
Yeah.
What if it is this? What if the number is... This one, where you at? You want to do this now? Where is she stowing?
I'm back.
You back? You should have never left. Fingers cramping up. Do you know what a micrometer is?
No.
Or a nanometer? Or a nanometer?
A
No.
micrometer screw guard.
No, not the tool, but the measure.
Oh.
Like nanometer. You ever hear about nanotechnology?
Oh,
No.
nanometer, picometer. Oh, those fine Measure.
Just like where you have kilometer, you also have nanometer, you know.
I'm not sure. That's from
Yeah.
feet.
What does it mean though?
I don't remember.
You don't remember?
This is feet or negative. I remember pico. I think
Nano is 10 to the negative 9.
Nano?
Yes.
I think pico is negative
What
12.
does that mean? It means 0, 1, 0, 1, point, 0,
0,
0,
0,
0, 0,
0 before reach the number.
0, 0, 0, 0. What should I put here? 0?
Yeah. Wait, what? No. 1. 1.
Let us make it a number. Let's put 3 times 10 to the negative 9. Alright? Notice here, look at the pattern here. 6 is representing of 1, 2, 3, 4, 5, 6. This is a 6. So this is a 7. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Sorry, so when you do negative, you go.
No?
No, sir, that's wrong.
That wrong?
Yes, sir, it's wrong.
Alright, let's go about it.
The number would be the 9th place.
She's going to prove right or wrong. What do you think, Tisson?
How about what?
Alright, so the first place, the 10th place, it is 10 raised to the what?
Negative 1.
Second place, it is 10 raised to the what?
Negative 2.
Negative 2. And this is 100.
Yes.
Yeah.
100. With the TH.
With the TH.
Yeah.
So, boom, bam. So if I had a number 0.05, it would be 5 times 10 to the what? 1, 10 to the negative 2.
Yes, negative 2.
Ah. So Tisson, is this correct? Stawin, is this correct?
Yes, it is correct.
Okay.
Stawin, Tisson say yes. So hold on. Careful now, you know. Don't let me trick you. Don't let me trick you now. If you have 0.05 and it's to the negative 2, if you have if you have this and it's to the 6, look what happened here. 1, 2, 3, 4, 5, 6. And look what happened here.
Okay, sir. So
1, 2.
the whole number, right? When you have
What's
a
the
whole
difference?
number, you would need to multiply in order to get the whole number.
Yeah.
But if you have a decimal, since you cannot write the division sign, you would actually write negative for the exponents.
Yeah. But what's the difference? Notice here I have 7 digits, right?
Yes.
Count them. I have 7 digits. And this is 6. and now I have 2 digits, and this is 2. Why we don't have 2 digits and we have 1 here, just like how we have 7 digits and we have 6 here? Why is that so?
Where is it, sir?
When we have 7 digits, the number on top of the 10 is 6. And now that we have 2 digits, the number on the 10 is 2. Why when we have 7 here, the number here on the 7, just like 2 here and the number is 2?
Oh.
Why is this not 1? Why?
Because 2.
But we could have said this is 7 too, so we should have 7 up here.
Decimal place.
You see, in standard form, when you're writing a number, you want the first whole number as well as the second whole number that follows. Once you get the second whole number that follows, you write it based on the place of that second whole number. With this number right here, 0.05, do we have any whole numbers in here?
No.
Huh?
No.
No.
Yeah.
So the second number that you reach, in this case, first, second, the second number that you reach in this case would actually be where your counter stops, because your second number acts as a cutoff point, whereas your second number here acts as a starting point in terms of you writing. So right here, if this holds true, 0.05 times 10 to the negative 2, it means for this to be 10 to the negative 9, you must have 9 places, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should be 3 right there. See the difference?
Yes.
Yes. So Starwin was saying, no, sir, you're wrong, but I wanted her to tell me why.
Okay.
So whole numbers and decimals, they operate differently. You have to watch them. So a whole number, a decimal is not really whole. So 3 times 10 to the negative 9, this is what 3 nanometers look like. Or nano. So imagine you have a number like this. You want to be writing this all the time, 0.803. When I say 8, I mean 8 zeros, then a 3. If you want to keep writing that all the time,
It would be annoying.
it would be very annoying. So it's easier to do this. And standard form is otherwise known as scientific notation, because in the scientific community, when things are measured, they are not usually measured, and their measure is not usually something we can write easily. So because we can't write them easily, we come up with a short way of representing them. And that is standard form, or scientific notion. So like distance from the Earth to the Sun, 149.6 million kilometers. Why we don't have time to write that? We don't have no time to write that. So we can simply say that it is 1.496
Times 10.
times 10 to the what?
8.
It's million. It's million.
I know, sir, but you actually placed the decimal place somewhere else. You added 2 digits.
No man, it doesn't matter how many digits we add. The number of places will remain the same, because this is representing the million. Alright? So in standard form, it doesn't have to be two digits or 1 digit. And 3. As in point, you can have 0.1496. For simplicity purposes, I can round it, meaning that I can have 1.5.
No, but sir, what I was saying is that you would be wrong there, because you would get a number smaller than the million.
Smaller than?
The million.
Smaller than the million?
Yes, because you because you move the decimal place, but you still have the same exponent.
I
So
move the decimal place because no, but remember in standard formula you cannot have more than one numbers to the left of the decimal point. You have that first number.
the
You have that
exponent
first
is
number,
correct.
and then everything that follows comes in with your decimal point. This number right here is not in standard form, 149.6 million kilometers. But to put it in standard form, it would have to be 1.496 or 1.5 million or 1.56. 1.5 times 10 to the 6 kilometers.
Yes.
Right? You get the same number.
Sure, you will get 150,000 if it is 1.5 times 10 to the 6.
You're saying if I had 1.496
For, yeah,
times 10 to the 6.
yes.
What would that give you?
It would give me 149,600.
Oh, it's time. Oh my, it's almost 8 o'clock.
That's what I was just gonna say.
Because I heard somebody parent asking if they're not done it. All right, I'll save the screen. I'll save the screen. Bam.
Yes, where is a student?
All right, my screen is here. I'll save the screen and then we'll pick up right here. All right,
Okay, sir.
we'll pick up right here.
Uh,
So, bye-bye.
Bye.
No, no, left.
You finished?